Welcome, everyone, to the 15th Annual Student Innovator of the Year. We're so glad you're here. My name is Nicole Stewart. I'm the director of the Women's Center for Global Leadership, which is housed here in the College of Engineering. To start the event, we are going to have Devin Johannesmeyer, our SIOY student director, give a prayer, and he is a student in mechanical engineering.
Our dear Heavenly Father, we're grateful for this opportunity we have to be here at BYU and to be able to use these facilities. We're grateful for the opportunity we have to celebrate innovation and for the great projects that these students have been working on. And we ask Thee to bless these students as they present so that they may be able to perform to the best of their abilities. And we say these things in the name of Jesus Christ. Amen.
Thanks to Devin for doing that. We're now going to invite our MC on stage. He is a BYU engineering alum, and he is also an original cast member from Studio C. Please welcome James Perry.
All right. Hey, everybody! This is exciting. I'm so happy to be here at the SIOY competition. For 15 years, BYU's Student Innovator of the Year program has helped students turn ideas into reality through funding, mentoring, and some healthy competition. So 2 weeks ago, 32 teams were competed at the SIOY Showcase, and the judges selected 7 of them to advance to this final competition. Our finalist teams will now compete for over $50,000 in prize money. Our SIOY competitors are judged on 3 categories. Engineering is 50%, innovation is 35%, and lastly, impact will be 15% of their score. All 7 of them are going to walk away with at least $4,000 just for making it this far. Then we will have our 3rd place winner winning a total of $8,000, our runner-up winning $10,000, and our 2025 Student Innovator of the Year wins a total of $12,000. Big deal for our innovators here. So you, our audience, will also be able to choose a finals favorite to receive an additional $2,000, and they will be just according to whatever you think they they'll receive an additional $2,000. Isn't that great? The plural of Lego. Okay. All right, we have some amazing prizes to give away tonight, and that's for you, our audience. So hold on to your tickets. We'll draw a winner after each team presentation. So if we draw your number, come all the way up, and our helper Devin is going to give you your prize, have you sign away your life, and then you'll be able to take home your prize. All right, so yes, it's very exciting. And now, for the meat of what we came here to do, we want to introduce our teams. So please welcome Team 1, Reality!
Memory foam, scratch-resistant lenses, cloud computing, and LASIK. What do these things have in common? These are what we call NASA spin-off technologies, or in other words, a technology that was invented for aerospace applications that has found its way to a local market here on Earth. With Reality, we're following in their footsteps. Through engineering and innovation, we're making an impact in the additive manufacturing and aerospace industries around the world. So what is Reality? Reality is a compact 3D printer that's designed to fly and print in space. It's lightweight and completely self-contained, meaning there are no external power sources or communications necessary. It utilizes a novel method of 3D printing that we've dubbed direct ink writing, allowing it to be gravity independent, and finally, it's durable enough to survive the loads of spaceflight. Now, there are a lot of printers out there that incorporate a lot of these features, but there's yet to be one that has it all in one package and designed for such extreme applications as Reality is. Let's talk for a second about direct ink writing. Direct ink writing is a 3D printing process whereby photopolymer resin is extruded through a nozzle and onto a print bed. It is then cured using a combination of direct and indirect UV light. This allows us to combine the benefits of standard 3D printing methods by printing in multiple resin materials at low temperatures with low power consumptions and the ability to print in any orientation. Now, our first attempt at direct ink writing involved a standard syringe for resin extrusion and a wall of UV LEDs that provided indirect curing. Our initial print tests were somewhat successful, but we did demonstrate that the complete 3D printer integrated system could function as expected with the structures and electronics. This first prototype was launched on a rocket last year. It went to 10,000 feet in the air, withstood 11 Gs along the way, and hit the ground with an impact velocity of 20 feet per second. After it landed, we conducted a successful dry run print test, again, showing that the printer could hold up and withstand even such extreme loads. With our current iteration, we're seeking to make it even more ergonomic, more mass optimized, and refining our extrusion and curing system. We're experimenting with different forms of directed UV LEDs, such as UV lasers, and we're inventing our own custom threaded syringe that will facilitate resin extrusion. This prototype will be launched on a rocket later this year. We're going 3 times as high with twice the amount of loads, after which we will complete a fully integrated print test while the printer is lying sideways on the ground. When it comes to external validation, we've spoken with NASA's additive manufacturing team who's interested in supporting small business ventures for research applications like in-space 3D printing. We've also spoken with the International Space Station's payload team, who's pointed us to different challenges and partnerships, and even the potential opportunity to test in microgravity. We've designed Reality to be safe enough to fly on the space station and meet those safety standards. We've also spoken with the Air Force, who offers similar types of research initiatives through the Air Force Research Lab, and even spoken to some contacts at Hill Air Force Base about potential research applications for fighter jets. Finally, at our own Brigham Young University, we're grateful to partner with the Rocketry Club, who's given us a lot of different opportunities to test our experiments, to enter it in international competitions, even winning one last year. We're also looking into potential research applications, how we can formulate our own specific resins to be incorporated with direct ink writing technology for specific manufacturing applications here on Earth. So memory foam, scratch-resistant lenses, cloud computing, and LASIK. The next spin-off technology is becoming a reality. Thank you.
Well done. At this time, you will have exactly 5 minutes for judges' questions.
Sure, I'll go first. Brady Wolford here. Nice job. Can you maybe provide some more detail on why you're testing, if I understand right, when it crashes? So it goes up, it comes down, and then you try to print afterwards. Kind of what's the purpose with that?
Yes, let's jump to one of our appendix slides really quick. This slide illustrates a little bit of our current prototype and testing metrics. At the bottom here, we talk about our high-power rocket launch test, again illustrating some of the same metrics as before. The biggest reason for that is because of the extreme amount of forces that we'll experience. On a standard rocket launch, you have forces as the rocket is flying in the air, as it's shaking, as it's vibrating, and then sudden impact forces, such as when it hits the ground, when a parachute is pulled taut, that kind of have these different force distributions on the printer itself. And so we want to make sure that the printer is robust enough to survive whatever load case it could experience during a rocket flight.
Are you also testing extreme temperature environments and any impacts on the resin? Are you using a standard 3D printing resin, or is this unique to your application?
Currently, we are using a standard printing resin as we work on developing the direct ink writing technologies. As I mentioned, we're looking to forward research to refine the type of resin we're using. And then once we get to that point, we will be testing in more extreme environments to determine which types of resin we would like to use and testing them appropriately.
So can you talk a little bit about how large this unit is and how big of a component it can produce?
Yes, let's jump again to our appendix. So the printer itself fits within 4U CubeSat dimensions. That's kind of a standard satellite dimension for when we're launching small sats to space. It's 100 millimeters square and then 400 millimeters tall. And so currently, about the lower half is composed of our electronics, and then the upper half is composed of the print volume. We're using a cylindrical print bed, allowing it to rotate with a radial gantry that moves along it. And so currently our print build space is limited to the build area beneath that gantry and within the cylindrical print bed.
Mike Esper, Chair, I have a couple of questions. First, all of your tests have been static. In other words, the forces have been experienced while the printer is not operational. Do you have any plans to test it in operation with forces applied? And secondly, are you planning to do any conductive resins to be able to print operational circuits with?
Absolutely. Yes to both questions. The current scope of our test now is to produce a completed print after landing, showing that it can withstand those loads and then print. In future years and future iterations, we hope to print during flight, being able to design some sort of vibration isolating system to print despite those loads happening at the same time. And then, yes, as you mentioned, different research applications. One of the reasons we want to print in multiple resins is for something like a circuit board, having varying electrical conductivities, varying thermal properties within a single print using resin extrusion.
Okay. One more quick question. Since this would be, at some point, I assume, some sort of a flight critical piece of equipment, have you made adaptations or accommodations for backup power supply?
That is not something we've
Turn the mic.
that isn't something that we've considered specifically yet, but as we're developing our prototypes, that is absolutely something we'll consider.
Definitely. I will point you to our appendix really quick as well, where we have been working with the requirements for the International Space Station, some different safety standards that they would like for us to adhere to. This is just a long list of them. Different things like that are incorporated as well in these safety standards.
Can you speak to battery life and how long this will run without recharging?
So currently we have some rough estimates based off of last year. I believe the intent was to be able to run on battery load printing for about 3 hours. However, we're collecting more information and getting a more precise number based on our new batteries.
Can you speak a little bit to maybe making a 1-inch cube, how long that would take to produce with this unit?
With our limited printing tests, we've not entirely sure what print speeds or like print volumes can be produced yet.
All right, thank you so much. Everybody give them a hand. Thank you so much, Team 1. Reality. I'll get out of the way. All righty, well done. Well done, that's awesome. I'm so excited about that technology because I have always wanted to 3D print something on a roller coaster. And I finally can. Okay, so we're gonna go ahead and introduce those judges. You've already got to see them in action, some great people. And I like to make this a little fun doing their bios. I'll introduce them in a fun way. In the past, I've done like each one is an Avenger, you know, depending on, like one of them was in aeronautics, so they were Tony Stark, right? I've done different things. I've done Taylor Swift songs. That was a fun year. There was a Swiftie like right around here who kept getting all of the answers right. It was amazing. I've done the love languages. And this year, I mean, everyone knows AI is on our brains. So I went to AI and I just said, hey, here's their bio. Tell me the fictional character that they remind you of. So this will be interesting, okay? So Judge 1, Mike Eskridge. Mike Ersch. Okay, he is a U.S. Army veteran, certified PMP, and Purdue University magna cum laude graduate. Development team recipient of the 1996 Emmy Award for the Tektronix Profile Digital Editing System. Woo! Not only can he invent that, but he can also say it, which is impressive. It was used in the movie Twister, so probably has something to do with, tornadoes looking good. He has held multiple engineering and executive positions, including COO, VP Ops, and President CEO, and currently is the Business Development Manager for Integrated Power Protection and Control Panels at Schweitzer Engineering Laboratories. So, as I said, I asked AI, who is he like? And it was Q from James Bond. Pretty cool, right? Mike is a brilliant innovator with multiple patents, an Emmy Award-winning tech background, and expertise in engineering and operations. So thank you, Mike, for being here. And now to introduce our second judge, Craig Paulin. He has a bachelor's in mechanical engineering from BYU and an MBA from Yale. He joined PSM Industries as a marketing manager, became the general manager, purchased the company, and became president. He built that company to a world leader in design and engineering solutions for the automotive, power tool, and sporting goods industries. He served as president of a $3 billion international trade organization and is on advisory board for Yale School of Management. Currently serves as BYU Engineering Executive Council. And so, his fictional character is Jay Gatsby from The Great Gatsby. Remember that crazy book we had to read in high school? Apparently, his journey from marketing manager to president and industry leader mirrors Gatsby's rise from humble beginnings to building a business empire, hopefully with a happier ending for those of you who are readers. All right, so Judge 3 is Ryan Woodley. Ryan is a proud graduate of the electrical engineering program here at BYU. He also has an MBA from Harvard Business School. Is currently the CEO of Netcraft, which provides cybercrime detection and countermeasure services to enterprises and governments. Before Netcraft, Ryan was the CEO of Progressive Leasing, which grew from $220 million to $2.5 billion in revenue and became public during his tenure. Prior to Progressive, Ryan was COO and CFO of DigiCert Inc. He was also an investor and board member of Utah tech companies Conservice and PDQ. And for our fictional character, Ryan Woodley is the Sherlock Holmes of cybersecurity. Okay, always steps ahead in the fight against digital crime. And I was kind of curious because he's got a varied background, and I asked, what about his experience in Progressive Leasing? And ChatGPT said, good catch. Here's an updated version. Sherlock Holmes meets Monopoly's rich Uncle Pennybags. I don't know what that means, but I thought it was hilarious. Thank you, Ryan, for being here. And judge number 4 is Brady Wolford. Brady Wolford is a senior principal R&D engineer at Stryker, spent the last 16 years developing innovative medical devices, has successfully taken a number of products from initial development to launch, providing millions of dollars in revenue, and is lead inventor on 10 issued patents with more patents pending. He has a bachelor's and doctorate in mechanical engineering here at BYU and was previously an adjunct professor at BYU and now president of the Convey It software company. His fictional character is Dr. John Hammond from Jurassic Park. That's right. His career in medical innovation, patents, and R&D aligns with that visionary scientist behind Jurassic Park, but hopefully with better risk management. All right, thank all the judges for being here, please. Okay, now, we do want to have a giveaway between every team, so we're going to go ahead and do one right now. You guys pumped for another giveaway? Let's do it. This is the Myostorm Meteor. This is a former SIOY competitor from 2018. They were on Shark Tank. This is a heated massage therapy ball, good for deep tissue muscle recovery. Thank you, Myostorm. And one of the founders is here today and going to be speaking to us later. So Let's get excited for that. All right, and get your tickets out. We have 981534. Going once. Going twice. Okay. Let's see. You guys, you have another chance. Oh, we got a winner? Prove it. Wait. Did we? Oh, there we are. Oh, from the back. Come on forward. Come and get your Miostorm. Devin here is going to help you. Go ahead to this side of the stage. Thank you very much for being here, supporting. All right, guys. So just so you know, before I bring Team 2 up here, I forgot to tell you that 4 minutes is what they have to present. Exactly 4. And if they go overtime, I get to jump up here and cut them off. So you can root for me or you can root for them. All right? And then same with the judges. They have exactly 5 minutes. So if I do, it's not because I'm mean, okay? It's because I'm fair. All right, so please give a warm welcome to Team 2 Lunar Watch Bands.
Hey guys, I'm Ammon Galart. This is Lunar, and I'm reinventing the strap. Now, you'll see here the classic situation where you get a beautifully, finely engineered watch, and it's to every spec that you want, it's to the specifications you need, but it comes with a band that breaks easily, is cheaply engineered, doesn't really fit you every time. I set out to fix that by making this Lunar watch band. Now, I'll show you how the engineering process started. It began with a sketch, and I started to realize that products like Bisham Belt and others that give a custom fit really work well, but they haven't been put on the wrist. And so I looked at prototype after prototype of testing this functionality out of a ratcheting buckle that gives a perfect fit every time. Now, it took 5 prototypes and countless months of looking through, testing functionality, hoping that it would work. And finally, I got to something that had functionality perfected every time. But functionality isn't enough. I needed to elevate the experience. Here comes the Lunar watch band, a patented buckle system that I sent in and got patented here that can be able to get a perfect fit every time and fit any watch piece. Now let's see how this compares to the market. The market offers 7 to 8 sizing options and only is compatible with really just one watch. Lunar, on the other hand, boasts 50+ sizing options and universal compatibility so that if you switch your watch piece out, you can keep your band and it fits any watch there. But what really matters? The experience. My customers say it best. It's so comfortable, I can't even feel it on my wrist. Lunar doesn't just fit your wrist, it blends in with your wrist. Now, looking at the plastic straps markets, they're expected to grow in billions by the next couple of years. That's billions with a B. There's plenty of room for Lunar to lead in this space. I started with watch straps, but why stop there? Imagine Lunar technology on backpack straps, ski straps, medical device straps, anything with a strap that fit and durability are key for. Lunar empowers you to thrive, whether you're running, biking, or diving into adventure. It gives you that perfect fit no matter the activity that you're in. Take swimming and diving, for example. You don't have to worry about your watch falling off to the bottom of the ocean or the pool. It stays secure on you every time. It is a perfect fit every time. This is expert engineering. This is Lunar. Thank you.
All right, now is your time with the judges.
So what materials did you experiment with in your prototype?
Yeah, so there were plenty that I could choose from. I began with 3D printing. So resin printing and just standard, gray color from Formlabs, and went through TPU, which is a hard plastic, but then the feedback from that was obviously such that it felt like a McDonald's toy. Couldn't really do that. And went to TPE. Still, the functionality was great, but it just wasn't the experience that people were looking for. And so I finally chose FKM rubber, fluorinated rubber. That's the same thing that the premium Apple Watch bands use that cost $50, $60. And then the buckle is polycarbonate, which is a hard plastic that's durable and very easy to mold.
Can you talk a little bit about the buckle itself? Have you done any reliability testing and comparison testing against other buckles out in the industry, kind of what that looks like?
Yes, let me show you here my appendix real quick, some of the testing that I've done. So you'll see right here on this slide that I took a couple watch bands off the market, like Velcro or just those 7 to 8 holes, kind of traditional watch bands, and other ones that have magnets. And as you can see, this system has proved to be the most reliable. I used a tensile tester to be able to pull it apart, and this buckle is very secure. And so that's why I told you that it can be used for swimming and diving or boating or whatever you need, that it will stay on your wrist and it won't be able to come off.
The polycarbonate's kind of a hard material. How does that feel, and how thick is the buckle? How does that feel against your arm?
So as I mentioned before, the customers that I've talked to say you can't even feel it on your wrist. It's actually so comfortable that it's lightweight. You don't even know that it's there. And I've made sure to make a flat surface on the bottom of the buckle so that it resides easily on the user's skin and that they're basically forgetting about it. Its thickness is similar to the band itself. It comes off just a couple millimeters on either side. And in the Z height away from the wrist, its profile is such that it's still low profile enough that it's not bulky.
Okay.
Good presentation, Hammond. Did you end up testing the band and buckle in all those environments you described, diving, swimming, running?
Yes, as you saw in the video, you could see it in all those environments. And I tested it with people that dived into water, and they dove, and they're like, wow, it's actually still on my wrist, unlike all these other ones that I dive in the water with that it basically break or fall off. So they were really happy about that. Biking, running, you can be able to adjust it within milliseconds, actually. You just pull the lever and put it back, and you're already a size bigger.
How did you manage the trade-offs, if there were any, and attract the right expertise to weigh in on not just functionality, but also the aesthetics of the watch band?
Yes, so like I mentioned, I started out with the most basic materials because I had to prove the functionality. That has to work. But then obviously customers wanted some materials that they were familiar with. So I looked to famous brands like Nomad and Apple that use the FKM rubber, and I asked manufacturers saying, hey, can you make this band with materials that they use for these really nice bands? And they told me that was the one they use and that it's going to be legit. And so when I've tested it, it's tear-proof, waterproof. You take it off before a shower, and after the shower, it's already dry. And I just went through that prototyping and customer feedback, just constant iterative loop of the engineering process so that I could be able to get the materials that are today.
You designed the look and feel, the style yourself?
Yes, I designed it, I submitted the patent and made it manufacturable ready, and talked to the manufacturers to get the samples to be able to come back and be able to sell them to people.
What was the uniqueness in the patent process? What did you state was different about this versus other bands that are out there?
So you'll notice that Mission Belt and other ones do have ratcheting style buckles, but such the way that I was able to integrate the lever arm and the action forces against the band itself is novel. So other things came up in the prior art search, but I made sure to go through them with the attorney so that it was all okay and that it wasn't infringing.
Congratulations.
Thank you.
Did you do any FEA analysis or anything like that on the design?
I'll have to talk to you after because I only got 4 seconds, so you'll have to email me.
Well, I could have cut you off. That would have been fun. All right, thank you so much. Well done. Nice. You know what I'm excited about? is when his strap can allow me to just have my entire laptop on my wrist. That'd be nice. All right, how about a giveaway, guys? This is Climate Hammock. This is a hammock that will never, ever break no matter what you do. It's impervious to all weaponry. I don't know. It's a cool hammock. Here, Devin is going to hold it for me. And the ticket number is 388283. Shout it out if you got it. Okay, don't fake me out here. All right, next one. I have it. Okay, 388282. This is not rigged. What's going on? All right, 388275. Am I going to win this hammock? All right, guys, 981554. I believe. Anyone? Who got all these tickets? What's going on? I probably shouldn't drop them on here. The producer's like, get those off the stage. Hey, 981549. 981549. Should I just toss it out? Should I just toss it? I'm going to after this. Oh, some of the things I should not toss. 388281. Okay. Is this a birthday joke? Guys, 388281. There are a lot in here. I'm getting a little suspicious. 981519. Is that real? All right, that's it. I'm tossing it. All right. It's kind of heavy. Here. Yeah. Oh, all right. Not toward the equipment. All right. Make it rain up here. Guys, this has been fun. But let's move on to the next team. Okay, team number 3. Please give a warm welcome for Sudstream.
Every year, over 1 million Americans fall or slip in the shower, leading to serious injury. And for over 17,000 of those individuals, those injuries result in early death. Millions more struggle with mobility issues that make showering more difficult than it needs to be. Many seniors view showering as a daunting and dangerous task, and they're not wrong. Wayne, an elderly man I spoke to, told me, when I reach for the soap, I have to let go of the rail and constantly worry I will fall and not be able to get up. That's why I created Sudstream, a shower system that integrates the soap directly into the water stream at the flip of a switch. Like a car wash for humans, Sudstream dispenses soapy, sudsy water through your shower head, thoroughly cleaning the body while enabling users to keep one hand free for support, making the process faster, safer, and more accessible. This solution significantly reduces shower times and lowers the risk of falls by eliminating the need to fumble with soap or other tools. Additionally, for those who need caregiver assistance, Sudstream provides a cleaner, quicker, and less invasive experience for everyone involved, restoring dignity and saving time. After realizing that nothing like this existed, I saw that there was a similar application in car washes. Based off on pressure washing attachment I was able to find, I then adapted and researched the technology for use in a shower using this attachment, some 3D printed adapters, and quite a bit of super glue. On first try, soapy water came through, but not exactly a shower, kind of more of a leak, if anything, but I made progress. By the 6th or 7th prototype, I finally had something that warranted being called a shower, It had soapy water and adequate water pressure, but I still couldn't turn off the soap, a problem not addressed in the parallel applications. From there, it was a lot of trial and error with my new mechanism. Some of the other issues I faced were optimizing the venturi diameter, making sure it didn't guzzle all the soap in one shower, and achieving a nice foamy wash. Additionally, some of the other things I focused on after that were creating a convenient and easy-to-use form factor. I spoke with over 100 people, including seniors, caregivers, and CNAs to gather feedback. The response was overwhelmingly positive, with caregivers noting how much time and hassle it could save, and seniors appreciating its simplicity and added safety. Here's how it works. SudStream uses 2 built-in soap reservoirs that attach to your existing shower. Through the venturi effect, the water flow draws soap into the water stream, mixing with both air and water to create a foamy, sudsy shower. Additionally, a simple toggle allows users to then switch between a rinse mode, a body wash, or a shampoo, providing full control with minimal effort. Over the past 9 months, I've refined this design through dozens of iterations. The current SudStream seamlessly addresses so many people face, and is now in testing with multiple nursing homes and households where mobility is an issue. A recent user, our friend Vani, said, "I absolutely loved how I was able to wash my legs without any effort. I seriously wish I could have this all the time." The market for SudStream is enormous. There are over 52 million seniors in the US, many of whom face mobility issues. Additionally, the tangential markets are equally promising, including for use in hotels, hospitals, toddler bath time, or even for washing your favorite pet. The market for accessibility products alone is projected to reach $42 billion by 2030. SudStream isn't just a product, it's a sudsy solution, a solution that improves health, safety, and quality of life for millions. It's a way to make showering easier and enjoyable again for those who need it most. Thank you.
All right, well done. You'll have 5 minutes with the judges.
All right, thank you.
Hey, Mike Esperts here. Given the different mixes of compounds and the viscosity and different soaps, how many different brands and products did you try it with?
Yeah, so I've tried it with a wide range of products. I currently have metering tips that I use, and in my next iteration, I'm making a dial to be able to adjust the amount of soap that is drawn into the water stream. But basically, it works with all soaps.
Is there any concerns with clogging? And if so, how have you gone about preventing clogging of anything that might build up?
Yeah, that's a great question. So the great thing about it is that when we turn it back to rinse mode, when you're washing yourself off, for the most part, it cleans itself out, washing through the shower head and pipes. And then for the actual tubes that go into the water bottle or into the soap bottles, it's usually closed off from air, and the air is usually what prevents or causes the coagulation on the bottles. So by not having air present, it's been fine in my testing.
To what degree did you calculate the introduction of the soap into the venturi chamber versus just brute force trial and error?
Definitely a lot of both. Because my initial calculations, I did try a little bit, weren't very effective just because of I'm not smart enough. But just like different things like things that lose water pressure throughout the system. With the trial and error, that's when I was actually able to kind of nail it down.
Okay.
Does the supply require you to use the bottles that come with it, and you transfer soap from whatever container you purchased it into those bottles? And
yeah.
then what does maintenance look like for the setup?
Yeah, exactly. So to your first question, it will have these 2 bottles that come with it, and that's just been made as a decision just mainly for aesthetics. You really could put any bottle on there. And then what was your second question?
Maintenance requirements?
Yeah, so in my testing, there really hasn't been too much of, if any, maintenance requirements. It's incredibly easy to install. You just take off the existing shower head and you'll put it on within like 2 or 3 minutes. And then as far as just probably, making sure that you're thoroughly washing or getting some water flow through the system so that the soap doesn't build up.
Did you also test this with conditioners? I see you have 2 different bottles in one of your shots there.
Yes, I have tested a little bit with conditioners. The conclusion is it's not great for conditioners, mainly because of just the way conditioner works. It's kind of meant to stay in your hair a little bit longer, and it doesn't really get like foamy. So the best applications have been with things like shampoo and body wash, which are really the things that are more essential, especially for those who need assistance in the shower or that extra support.
You know, you're making this for seniors. Is it possible you're making the floor more slippier, as you are dumping so much soap on the floor versus, you know, using a bar of soap?
Yeah,
And it may be more dangerous?
Yeah, that is a concern that some people have had. And once again, that's why it's in testing with multiple nursing homes and with people to just kind of get a feel for that. But in my personal testing and the testing of others, it really doesn't have any more, I guess, slickness than your average shower would.
Okay.
What applicability do you think it has outside the senior market?
Yeah, so that's what I'm most excited about. I see the most need up front for seniors, but I think there is a lot of area to expand. For example, one of my favorites is for hotels. You know, instead of getting those little dinky little soaps, you can have a big soap bottle that's kind of behind the tile or something that saves time for and money for the hotel and a better experience for the customer. As well for use for like pets, something I've been hoping to expand into as well is like for a kitchen sink for like washing dishes.
Have you adapted the handle mechanism at all for people with severe handicap?
Yeah, so that's what I'm doing with my testing to kind of gather, is this big enough? I've adapted it a couple times. Right now it's pretty big and it's pretty easy to move back and forth. Obviously there will always be some people that aren't able to do it, but from what I've seen, if you can turn on your shower, then you can probably do this as well.
All right. Well done.
All right, thank you.
Thank you so much. Awesome. Thank you, SudStream. Okay, so you know what I'm excited about is I have kids, and I would use that for my kids because I don't have mobility issues, but when I bathe my kids, suddenly I do. So that would be very helpful. And in keeping with the theme, our giveaway is phone soap. Do not use his product on your phone. Instead, use phone soap. This is a previous SIOY competitor. They have several products on the market at phonesoap.com. It helps to sanitize your electronic products. All right. Let's see how this goes. All right, we've got 981540. There it is. There it is. We are back in business. All right, come on up as quickly as you can. Just go ahead and come through here. You can go behind there or through here. And Devin's going to be right here on the side to help you retrieve your prize. Is there a person? There is a person. All right. Hey, congratulations. Well done. Okay. Oh, thank you. Nice to meet you.
Nice to meet you as well.
Off the stage, please. Yeah, no need to come on the stage, but I'm so glad that he did. So glad that he did. Introducing Team 4. Give a warm welcome to Varroa Tech.
This is a supermarket. Sorry. And this are your options without bees. Bees are essential to all crops because of their pollination. And it's beekeepers like these, day in and day out, distributing hives across the US that give us the food supply we need. This is a problem. This is the Varroa destructor mite. This invasive parasite kills hives, and after only a 3% infestation rate, a hive is considered untreatable. This leads to 40% of beehives dying each year in the US. This results in a $648 million loss in honey and a $1.2 billion loss in unpollinated agriculture. Beekeepers are currently spending a quarter of their budget to treat for these mites, and 80% say that this is their #1 issue. There are some current solutions in place, such as this little cup, in which you throw hundreds of bees in, you wash them with alcohol, and you count the physical mites on the bottom. Or a lot of beekeepers will just use a spray and pray approach, where they fumigate all of their hives, whether healthy or not, obviously harmful for the bees. Beekeepers know how to treat, they just don't know when, and current methods take too much time, too much money, and are endangering bees, giving us too much risk. That's where we come into play.
Introducing Varroa. Varroa is a device that goes on beehives and gives accurate Varroa mite infestation levels in real time without harming a single bee. It works by gathering data from the fumes that bees naturally give off. This data is then fed into machine learning algorithms that determines a mite infestation level. Our device attaches to the front of a beehive. It gets screwed in, and a small tube is run in the bottom of the hive. The tube is then connected to an air pump, which pulls in the natural fumes that bees give off into our device and across an array of sensors. This data is then transmitted to our database where the machine learning algorithms go to work, and they determine the mite infestation level. These levels are then made available in the app where beekeepers can see quickly. These hives need help, these hives don't. This is a typical looking bee yard with about 100 beehives. This would look something like this in our app, and all the mite infestation levels would populate for each hive. Beekeepers can see quickly, boom, here in yellow are hives that can be treated and recover. Here in red are hives that will not recover and we need to get rid of and replace with healthy hives. This leads to an overall healthier bee yard and shaves a typically 16-hour testing process down to just 5 minutes. Varroa also saves beekeepers on average $113 per hive per year. And over the past year, we've been iterating and perfecting what we have, and we will continue to improve the product that we have. What we have is currently on 40 different beehives in Southern California, actively gathering data, and we've been able to achieve a classification accuracy of up to 95%.
But we're not alone. We're partnering with UCR, UC Davis, and Utah State to expand our data and research. Not only that, we have 150,000 commercial hives willing to test with us this spring and summer. Now, this is our 6th iteration of the device, and we've come a long way, with every iteration being more accurate and better than the one before. The opportunity is this. At scale, this will cost us $18 to make. Our willingness to pay is $175, giving us a $157 margin. Not only this, we've run Facebook ads. With a $70 ad budget, we've had 91 people experiencing this problem reach out through our website and click Buy Now, giving us only a 77-cent customer acquisition cost. This is a real problem, and we're targeting a $1.5 billion market with a total of $11.8 billion market. So please, join with us in being part of produce production.
All right, that was very good. Yes. Got to cut someone off. You guys did so good. You'll have 5 minutes with the judges.
Yeah.
And only 5.
Thank you.
Good presentation. Can you guys say more about how the sensor works?
Yes. Sure.
Yeah, so we're using an array of different sensors. These are semiconductor gas sensors. So what we're measuring specifically, we're measuring a handful of easy to measure gases, so things like CO2, nitrous oxide, total volatile organic compounds, and then temperature and humidity.
Anything novel about the sensor you're using, or is it off the shelf?
Yeah, so the sensors in particular we're using are not novel, they're off the shelf. What's novel is our technique. The bees essentially are giving off certain types of fumes, certain types of gases, and those levels will change in times of infestation. And so our approach is what's novel.
Can you talk a little bit about the size of the data set that you've used for training and how you feel like that's sufficient for the accuracy that you're getting?
Yeah, so the data set that we've used so far is based on 40 different hives in Southern California. The testing we've been doing so far has been using a variety of machine learning algorithms. And what we're doing so far has been classification algorithms. So we're looking at a threshold of infestation and looking for a high, low, above or below that threshold. This is mainly to basically prove that this is something that can work. And in our testing over the next several months, we'll be looking at regression testing so that we can look at the actual level specifically of infestation.
Yeah.
Have you done any environmental testing in your assembly?
Yeah, so that's one of our next big steps. We've done some minor testing. We've been testing it outside on real hives and haven't had major issues. But we know that weatherproofing and robustness are two of our next major steps as far as developing our housing, our electronics. And that's one of our next steps in prototyping.
Have you pre-calculated any changes in your algorithms based on the weather?
We haven't yet. That'll be part of our next stage of testing and data collection, is being able to gather data not just in that one region of Southern California, but getting multi-regional data, multi-season data, so that we can have a model that will work no matter where you are in the world.
Does the model change according to what kind of bees you're using, or are there mites in Italy that are different than mites in California?
Yeah, I could go ahead and answer this one. So there are 7 different common types of honeybee, pretty interchangeable across the globe. Some are more resistant to mites, some are less resistant, but across our data, we've tested on a mix, and they're showing similar results.
What got you guys interested in this? I mean, you just don't sit there in a chair and come up with this idea. Somebody must be a beekeeper or that you know?
Sure. We have a slide in our appendix. We can find it really quick. So we were part of a program in this last year called the Crocker Fellowship at BYU, which encourages innovation based on existing problems. And in that process of finding a need to meet, we were talking with a beekeeper, and he talked about Varroa as one of his biggest problems. And specifically, he said that in his experience, you can usually smell it when there's something wrong with your hives. And so that is what got the ball initially rolling of, is this something that we can do in an automated format?
Yeah. We took the research from the University of Poland, who had been, doing sensing with remote sensors in 2020, and they've proven it to work. So we replicated it with more commercial components.
Nice. Well done.
Is there any degradation in the sensors that you have to replace them, or kind of what is the life cycle of the assembly there that you put in and do the measuring with? How long is that?
Yeah, most of these sensors are built with a long life cycle in mind, so they should last for months or years at a time. A lot of them do have a sort of recharge period, so an eventual production device will need to be able to have sort of a period of time where it'll run on ambient air so that device can reset its sort of baseline thresholds, but they are designed to be able to last for a long period of time.
Great.
Do you have anything built into your software to tell the beekeeper that the battery is running low?
Yep, that will be part of it. The battery we have set up now, with the fact that we'll be collecting data in sort of short spurts at a time, our battery should last for a few weeks at a time, but that'll be built into the software, so they'll know when to change. And we are looking into solar as well as a way to hopefully keep that topped up over time.
Thank you for your time. We appreciate your questions.
Thank you.
Thank you.
Awesome. Thank you, guys. All right. Guess you know what I'm excited about? Saving the bees. Yeah. I am. I truly am. Okay, so next giveaway. We have this Lego set of the International Space Station, 864 pieces, 8 adjustable solar panels. Okay? This is amazing though. It actually floats in space. Now you got it. All right, there you go. Okay, who's gonna win it? 388285. Yes, I hear a yes. All right, we have a winner. Love it. Thank you. Come on up, and Devin will help you to receive your prize. Thank you for being here, participating, supporting. All right, guys, we are over halfway through our 7 teams. We have Team 5. Please give a big welcome to DryRise.
Let me introduce someone I know personally. This is Preston. When Preston was 14 years old, going on camping trips with friends was kind of a risk. This is because Preston struggled with a secret he was hiding from them. That secret is a condition called nocturnal enuresis, more commonly known as wetting the bed. Now, would Preston bring pull-ups on a camping trip? No. Preston could not risk letting his friends see diapers in his camping gear. So, Preston decided not to do that. And he went to bed and unfortunately ended up wetting the bed the night before. Now put yourself in Preston's shoes. Imagine the panic you would feel in that sort of situation. And now it's time to get vulnerable because the reality is I'm Preston, and this is a real experience that happened to me. And I know deeply and personally the kind of pain that these people feel when they go through these situations. The humiliation, the shame. There are so many people today that struggle with this.
Over 3% of the non-geriatric population in the US has bedwetting accidents. So what does this number equate to? Well, that's the population of Utah and Idaho combined. And these aren't the only people that we can help with this innovation. There's also those who have spinal injuries where they have a functioning bladder, but they can't feel when they have to go. In addition to that, there's those who have overactive bladder syndrome. So we talk to these people, and the majority have multiple bedwetting accidents every week. Their biggest concern is the emotional impact, and almost all of them say current solutions are ineffective. They've tried the diapers, the wet alarms, the medications, but these solutions aren't solving their physical, social, and emotional needs.
So we're excited to present our solution, a way to predict when these accidents will happen and prevent any accidents from happening in the first place. Let's talk about bioimpedance. This is a smart scale that has 4 electrodes on it. These electrodes, when stepped on, will give an impedance value that is translated into a body fat percentage. We take this same technology and we put it into the bladder area, where it will send a signal through the bladder, giving us important information. Now, a bioimpedance sensor is connected to an ESP32 microcontroller, which is hooked up to the cloud. That connects to a multi-platform app targeting Android and iOS that looks like this. It goes back into the cloud into an S3 bucket for further data processing. Then it goes into machine learning models to be processed with AWS SageMaker so that we can predict when an accident will occur.
This is just one example of the many pieces of data that we've gathered. Here you can clearly see the difference between a full bladder and one that's recently been emptied. Now, to get to this point, we started by testing on a gelatin mold filled with water. And from there, we were able to figure out how to use this bioimpedance technology on our own bodies to see our bladder levels. So now we're working on making the device smaller, sending it out to our list of testers so that we can get ready for market.
Now, our people are very disappointed at the lack of support they've received. I know I was. Some are so embarrassed that not even their closest relatives or loved ones know about this. But we are so excited because we know that our technology can save them from the same humiliating experiences that I experienced when I was younger. Thank you.
All right, you'll have 5 minutes with the judges.
Thanks.
So Mike Gaspard Chair. So since the problem is they don't awake to solve that problem, what do you do with this data to bring them out of a slumber to prevent the accident?
That's a great question. So with the phone, we can, if it's an adult, they'll likely have a phone. And so we can send an alarm to the phone where if our predictive machine learning models predict that an accident will happen, let's say in 15 or so minutes, then it will send an alert to the phone or an alarm to alert the user. And honestly, now is a great time to be using machine learning just because of this, whole AI boom that we're in. Machine learning models have become more accessible than ever before.
Do you have plans to adapt a small module with an alarm for like children that don't have a phone?
That's a great question. I've worn a couple of prototypes already that use haptic feedback to wake someone who's in deep slumber. They're fairly comfortable, but will bring you out of a deep sleep.
Can you give us an idea how big, what this looks like, how thick it is? Are you that far along that you have a kind of a prototype that is working?
Yeah, we're working on miniaturizing it. I'm currently wearing a early testing unit. It fits right in my pocket, and it uses electrodes that are stuck to my skin.
Okay.
In your training set that you're developing, how do you account for like different bladder sizes and any other characteristics that might be important to make sure that you can detect correctly?
I can address this question. So every body is different, and that's why it's important that there's a calibration period. It's likely that they will have to wear some of the preventative measures, like pull-ups or adult diapers, before the prediction models become accurate enough to predict when they're going to have an incident.
Got it.
So,
Do you anticipate this is something that you would be sold, say, in a drugstore or online? How would you approach people to give them awareness, and how would they purchase it?
Yeah, so we currently plan on starting online sales direct to consumer. And from there, this is a quality of life device, so eventually insurance would pay for it, and we'd like doctors to recommend it in their practices.
so thinking of the case of nursing homes or severe care facilities, would it work on the bowels as well as the bladder?
Go ahead.
Not at this time. Currently, the sensor looks directly at the bladder. We would need to find another way to look at the bowels.
Yeah, up to this point, what's been some of the biggest challenges you faced, and kind of how have you worked through those?
Some major challenges have been creating initial proof of concept and then working through what it takes to produce cloud computing. Some early challenges were finding sensors that could actually look at the bladder and produce results that correlate to changes in its levels. Now we're working through what does it take to build out an algorithm that can reliably tell you, hey, you need to get up. Because we would hate to have someone that has an accident while using our device.
Have you engaged with underwriting laboratories or any other national certification labs to make sure that you're developing it according to safety measures?
Right, so before we send it out to testers, we have to pass this through a institutional review board. Luckily, we have one on BYU campus that we're working with right now with our lawyers. So once we do that, we'll be able to follow all the regulations as we send it out to people to test.
Are you currently working with any professors here or elsewhere on this project?
Yes, shout out to Dr. Manwaring.
Yeah, in addition to that, as you can see in our appendix, we have also been working with 2 doctors along the way thus far. Both of them have given us invaluable insights as to the mechanics of the bladder and the kidneys and things like that.
Awesome. Thank you so much. Give them a big hand. All right, you guys, you know what I'm excited about? Hear me out here. Hear me out. Okay, I'm a filmmaker, and when we want to see if something works, we put it in front of a group of people to watch and give feedback. Now, what if we could use this technology to uninvasively put it on their face and detect when they're about to cry? Right? Just saying, pretty good application. All right, how about our 5th giveaway? This is a video projector. Video projector. Oh, look at all the wonderful features. Who's going to win this video projector? The features may be the ones on the box or the ones on the screen. Who knows? All right. 388-321. I need to hear a shout. Put that away. Safekeeping. Next. 388-325. We got a winner! All right! Woohoo! Congratulations on your video projector. Come to the side here. Devin will get you your prize. Thank you for participating. Thank you for supporting. And now, guys, 2 more teams left. Aren't these some amazing technologies we've seen so far? It's incredible. I can't believe it. The things people come up with. And we've got 2 more. So let's give a warm welcome to Team 6, Indel Industries.
Hello, my name is Peyton Jackson.
And I'm Jared Wieland.
And we are Indel Industries. Indel Industries is a gene therapy company combining both chemical and genetic engineering to revolutionize the way that we treat cancer. While I was serving my mission, I got a call one week and found out that my amazing mother had breast cancer. After watching her overcome that and learning about genetic engineering here at BYU, I knew there was a better way to do this. That's when I met Jared, and together we founded Indel Industries.
Now, as Peyton and I began to tackle this problem, we found something interesting, and that's that African elephants, with their huge biomass, when exposed to similar carcinogens, rarely to never get cancer. That's because in every cell in this massive elephant's body, it has a proliferance of a tumor suppressor gene called TP53. Us as humans, in our cells, only have 1 copy, one from mom and one from dad.
To give you a little introduction to the TP53 gene, it's right here. It is a tumor suppressor gene, and it acts like a sort of police station within every single one of your cells. It sends out these police officers that scan your DNA for damage. If that damage is detected, it eliminates that cell. Now, however, what can happen is this police station or gene can be mutated, as it does in over 50% of human cancers. Now, if that happens, the police officers that are sent out are ill-equipped to detect this DNA damage. So if we have a similar situation, that cell is allowed to replicate and replicate and replicate, and that's where we get cancer.
Now, it's not as easy as just injecting a healthy form of this police station and then boom, right? It's a little more complicated than that. The first roadblock that me and Peyton had to overcome is that your body is really good at detecting foreign substances and then immediately degrading them. So Peyton and I went through the iterative process of chemical engineering to develop a specialized LMP, or small fatty molecule, that would carry our genetic treatment specifically to cancer cells and deposit the genetic treatment there. Now, even when that genetic treatment is deposited within the cancer cells, there's still a long road to gene expression of the healthy police station within that cell. Peyton and I started with genetically engineering a DNA construct that had all of the DNA machinery necessary for that healthy police station to be expressed within the cancer cells. The problem is just like the body, your cell's really good at recognizing that foreign DNA and degrading it. So Peyton and I went back to the drawing boards and used chemical engineering to develop a specialized coating that would supercoil our DNA and then localize it with the nucleus. Next, we needed something that would take that DNA, uncoil it, and then integrate it into the cancer cell genome. That's where our specially engineered transposase enzyme came into play.
Now, once we have our chemically engineered enzyme and our genetically engineered construct inside of this nucleus of the cell, it acts like a hard reboot, putting in this new police station and sending out healthy police officers, which immediately recognize the massive damage to this cancer cell and shutting it down.
Now, how this would look in humans is an intravenous injection in which this genetic therapy travels throughout the bloodstream, identifies those specific cancer cells, reboots those cancer cells, and causes controlled cancer cell death.
At Indel Industries, we want to target the very root of the problem. So many of today's treatments, whether it be chemotherapy or radiation therapy, are superficial. It becomes a race between you and the tumor. Who can last longer? That's a dangerous race, and we've been running in it for far too long. It's time to change. The unfortunate statistic is that this year in the United States, over 2 million people will be diagnosed with cancer. And unfortunately, over 600,000 people will die of cancer this year. We believe at Indel Industries, by combining both chemical and genetic engineering, we can revolutionize the way we treat cancer. And we have the potential to take this number down to this. Thank you.
All right. Well done. You'll have your 5 minutes with the judges.
So,
Go
ahead, Mike.
So is the intention that when this gets in there and reboots the cell, it triggers apoptosis? Is that the end result?
Yeah. Yes, that's correct. So there's pathways inside of your DNA that are often not mutated in cancer. And so once you've rebooted this essential tumor suppression gene, it actually activates those downstream genes and then causes apoptosis, correct?
And those downstream genes are rarely to never mutated in the actual cancer. It's just the P53 that's the real holdup.
There's existing drug development research focused on mutated P53 genes. What's novel or unique about your approach? Is it the delivery mechanism you intend to use?
That's a great question. So all of the treatments right now that are currently used are things like small molecules, radiation therapy, chemotherapy. The ones that you're specifically speaking to where they actually use P53 generally use mRNA or protein. We're using a genomic integration, which has never been done before. We're also combining several novel technologies into a new way that hasn't been seen before in the market.
Can you talk through maybe some of the validation or verification of this method? Like, it's a novel method, patent pending, but what's actually been done to test that it works?
Yeah, so in our supplementary slides, we touch on this. Let me just thumb over to that. So right now, we have been doing testing in both Drosophila melanogaster, which is fruit flies, and in vitro studies in cells. In Drosophila, we've been studying the effects of the copy number, which is how many of the TP53 gene you have inside each cell. And we expose these flies to an extreme carcinogen and then track survival rates. Right now, we're seeing dramatic differences between those without the gene and those with the gene. And then we're creating a new DNA construct to put in flies to have more copies of the gene and validate our theory.
Yeah, and then we've also been testing in vitro, like Peyton touched on. We're growing up a triple-negative breast cancer cell line and then testing our transposon-based system on that. So our DNA construct, we're testing that and validating it in vitro right now.
Can you talk a little bit about, I mean, you say off the bat it works in 50% of cancers. What indicates that it would work or doesn't work in certain cancers?
Yeah. So what happens is that police station is able to stave off mutations that happen in everyday life, and it makes sure that those damaged cells are eliminated. However, you can accrue all these mutations, but it's once that specific police station gene is mutated, that's when you start to get this cascade into cancer. And so we are attempting to replace this police station and reboot that system that protects against it. And so over 50% of human cancers have this mutation, and a lot of the others have epigenetic silencing and other effects. And so by putting a new healthy copy into each cell, we hypothesize that there will be dramatic effects.
Thank you.
And who are you working with in conjunction? Is it just the two of you, or are there?
Excellent question.
folks that
In
work
our
together?
supplementary slides, we have, there we go. Sorry, 1 second. Right here, this is our team. So we have Jared and I, and we founded the company. We came up with the idea together. And then as we continued pushing along, we knew that we had quite a mountain to climb if we were going to attempt to treat cancer. And so we brought on both Dr. Jared Barrett and Dr. Tim Jenkins, which are both professors here at BYU.
What do you feel is like your biggest hurdle still?
Yeah, so I think the biggest hurdle is once we get data collection, next is IACUC approval, which is a long process, and mammalian testing, which is also a long process, to be able to submit our IND report. So we foresee that the biggest holdup and roadblock in this genetic treatment is most likely FDA approval and FDA preparation.
All right. Thank you so much.
Thank you.
Thank you so much. Wonderful. I mean, I think it's pretty obvious what I'm excited about there. Curing cancer. That's amazing. Let's have our sixth giveaway. So this is the JBL Charge 5 speaker, portable Bluetooth speaker, and it's got a giant battery so you can listen to music and charge your phone, or just listen to music for a very long time. And who will be our lucky winner? 981556. Yay! No? All right. All right. 388317. Oh, I just hear whispers. Curses. Oh, you got it? All right, just in time. Come on up, everyone. Give him a hand. Go ahead and see Devin over here at the side of the stage. Thank you so much. And we are now at our last team. Aww, it's almost over. But hey, it's going to be a great final team, so let's get excited. Let's have a warm, big welcome for Team 7, Brizi.
Close your eyes and imagine you're in a sauna. It's hot, you're getting a little sweaty. Now I'm gonna put a lazy boy in there with you. Go ahead and take a seat. I'm gonna put 2 big straps over both your shoulders and tighten you in really tight. How long could you last? 10 minutes? What about an hour? Kids are in this situation all the time. Car seats are so important for safety, but on hot days, they turn into mini saunas. When it's 90 degrees outside, the internal temperature of your car can reach 140. Kids heat up 4 to 5 times faster than adults, and they can't regulate their own body temperature, making it easy for parents to misjudge how their kids are feeling. Even with the AC on in a car, the cool air rarely reaches kids in the back seat, meaning they are uncomfortable, sweaty, on car trips that last anywhere from 10 minutes to 1-2 hours. Giselle Martinez was a beautiful baby girl who tragically passed away from hyperthermia in a car that was running with the AC on. While rare, this shows that the worst can happen if nothing is done. We are Brizi, a company dedicated to relieving the distress of our most precious gifts, our children.
Hundreds of parents in the US have told us that this is a problem that they struggle with. Their babies are uncomfortable in their hot car seats, but they don't know what to do, and they feel terrible. They want a solution, so they've spoken with us and helped us identify what key features a solution should have. It should target the key hot area, where the baby needs to be cooled at the back. It needs to be portable and move with the car seat. It needs to last and cool the baby for hours. And the parents want to be involved. They want to know how hot the baby is, and they want to know how and when they can come to the baby's rescue. Now, this isn't a novel issue. Many people have been aware of this, and there have been many attempts to solve this, but unfortunately they don't measure up and they fall short of these 4 design criteria. The noggle blows air at the baby, but it doesn't get behind their back. Freezable gel inserts cool the baby from behind, but they end up defrosting and have to be taken out after 50 minutes when they go warm. Neither solution keeps the parent informed, and they really don't know how their baby is doing. we recognized that a better solution is needed. Over the past year, we've run cooling effectiveness tests to test heat sinks, coolant, tubing systems, and circulated air. And we found that targeted circulated air is the most effective and least invasive solution that will fulfill these design requirements. Through 4 full prototype iterations, we found that we could lower the temperature within a car seat by 40 degrees in 5 minutes.
Introducing the Brizi car seat, a smart ventilated system that cools down kids and meets these 4 design requirements. We have a custom airflow duct that sends air behind the baby and cools them from the back forward. This promotes evaporative cooling and targets the hot spot. We have a rechargeable, high-powered battery that mounts to the side of the car seat, running the system for over 4 hours, allowing parents to take it with them on the go. We have 2 in-series fans that promote a high-flow system. Similar to a ceiling fan in a hot room, this circulation of air alone will cool down kids. Additionally, we have 4 thermistors throughout our insert that send temperature data from below the baby to parents to an app. Parents can then manually operate the fan as well as set temperature thresholds to automate the system. The Brizi insert not only meets design requirements from the parents, it also only adds 3 pounds to the car seat, and it has a washable, removable cover, and we are going through testing to get it safety certified.
We've taken our insert to over 500 parents, and they absolutely love it. 94% of them saying that this is the solution they need. We've built a wait list of 103 parents ready to buy, and 83 parents willing to beta test. We are positive that this will have a huge impact. There are 2 million babies born every year in hot US states, and parents want their children to be comfortable. Thank you.
All right. Well done. We have 5 minutes with the judges.
So I've got a pretty big herd of kids. They're all grown up now. I've carried my fair share of car seats. What's the amount of weight that you're adding to this? Because car seats are also meant to be picked up and carried outside the car.
Yeah, for sure. That's a really good question. Our system only adds 3 pounds to the existing car seat, and we're hoping to cut that down even further as we continue to iterate and develop our product.
There are a lot of safety and regulatory concerns associated with car seats, labeling requirements, certification requirements. To what extent have you guys started to do any of that? Done research on it, sized up how onerous that'll be?
Yeah, we're currently working with members of the NHTSA, the Juvenile Product Manufacturers Association, and Safe Kids Utah, because safety is our biggest concern with this product. And it'll go through independent laboratory testing that does crash testing and make sure that it doesn't mess with the structural integrity as an aftermarket product in the car seat.
Have you researched how long it'll take to go through all of that testing and approvals?
It takes about 3 to 6 months to go through the whole process.
And then have you looked into the liability associated with manufacturing these products?
Yeah, it's very important that this product is safe to use. So once they show that it doesn't mess with the car seat safety when it goes through a crash, manufacturers of car seats can approve it on a list, and ultimately it won't mess with it, so parents don't have to worry about it messing with the safety of the car seat.
It won't take the warranty away of the car seat.
Have you looked at adapting this to any other uses, and specifically like bed-bound patients or people in wheelchairs that have the same issue?
We know there are hundreds of different applications for this product. We've talked to people who have thought about using it for baby carriers or for backpacks in general, but also wheelchair uses. There are a lot of situations where people are just overheating, and something like this, even for adults, could help.
Can you talk through your process that you took to get to where you have the venting holes and the fans, why you chose 2 fans, and just kind of what your process was to get to your design?
Yeah, for sure. In our appendix, we have a chart showcasing some of the prototyping that we have done getting up to this point. And so we've done some hand sketches. We've looked at different cooling methods, such as like trying to get some sort of coolant liquid, and been in discussions with parents about kind of what they would prefer that to look like, and modifying our design to match what they want.
How many models of car seat have you fit checked it against?
We have tried this prototype in 3 different car seats that are all different from different manufacturers, different models, and with little adjustments along the way, it fits in all 3.
Seems to me you have 2 different products here. One is really the app-based product that could sense your child's temperature, and if it's alarming, I guess you could raise or lower the temperature in the car. And then you're also selling a coolant system for the child, baby. Have you thought about splitting this into 2 different products?
I'd say honestly, we haven't thought about splitting it into 2, but that's definitely an option. I think the nice thing is because we already have the insert in the car seat, we can embed those temperature sensors or those thermistors in the insert, which makes it a very seamless process. But that's definitely an option for other iterations or other products.
Yeah, I'm just wondering if there'd be a more of a clothing-based, cape-based system, you know, that you could just slip over your child and it would sense their temperature, put the sensors there. That way you could maybe hit the market a lot faster than
for sure
having to go through the whole approval process.
For sure. I love that. I think the key thing that we need the insert for is cooling down the back of the baby, because that's where the main heat source, the most heat is getting trapped. So that's why we do have the insert. But I love the idea of getting to the market quicker with something that works.
All right. Thank you so much.
You.
Thank you. Well done. Woo! I'm just excited in general, guys. This is awesome. That is our last finalist. Please give them all another round of applause. We've excused our judges. Our judges are deliberating, and when they come back, we will announce the 2025 Student Innovator of the Year. So for now, we have our 7th giveaway. Shall we? Now, this is probably our biggest giveaway and our smallest. Okay? Apple AirPods Pro, 2nd generation, 2 times more noise canceling than the ones I have. All right, here you go. So, who's our lucky winner? If I can use my fingers. 388234. Oh, missed opportunity. All right, it's okay. 388264. Woo! All right, someone's excited. Come on up. Come get your AirPods. You enjoy music and podcasts and audiobooks. It's just anything, that you could listen to. All right. Awesome, guys. So we have some great things for our audience here while our judges deliberate. One of the things is that our audience needs to vote. So we need your help to vote on an audience favorite. We have our top 3, our first place, second place, third place, and an audience vote that's separate from all of those. Now, the judges have to use the rubric. You can vote however you want. You can vote by how cool their hair looked, whatever you think makes it your favorite, okay? So submit your vote using the QR codes that is going to pop up on the screen here. Only 1 vote per person, and you must be here in person to vote. So please don't send this out and, tweet it to your 1 million followers or anything like that. You have 2 minutes to vote, and we'll start the timer now. All right, thank you for your participation. The voting is now closed. All right, we have some special guests with us today, and we want to introduce our speaker after we thank our BYU Executive Alumni Board, who is with us today. Thank you so much for being here, members of the Engineering Mentor Alliance who helped judge the preliminary competition. We're so glad to have you. Everyone, please give them a big thank you for being here with us. And we are very excited to have the former SIOY competitor and co-founder of Myostorm here with us. Please welcome Jono DePerry.
Hey everybody, can you hear me? Super excited to be here. This has been awesome. Congrats teams, super put together, way better than when I was here several years ago. And I think it was 2018, I think I competed in SIOY, and I've pretty much been back here every year since, whether just watching or helping judge or coming and speaking. And BYU asked me to come today and share a little bit about my story, my journey, a little bit more about Myostorm and my experience with SIOY. But yeah, back in 2018, was an engineering student. I did graduate from mechanical engineering here at BYU, and was a part of a research group and was learning some really cool things like a lot of the students and the teams here. Part of the vibrations research group. And with everything that I was learning, I was kind of encouraged by professors, by friends to submit this idea into the Student Innovator of the Year competition that I'd been working on. I was a nerdy, boring engineer and had no desire to be on stage or talk to anybody, so it wasn't really something I was very interested in doing. But after a lot of pressure, I decided to kind of go for it. The whole process was amazing, and SIOY has evolved a ton since I was a part of it, and it's even better now. But even back then, the mentorship, the whole path to get here, to be presenting on the stage, just helped me develop this concept and this idea, and helped me start thinking about it as an actual a product, right? Not just research, not just as a student. So I entered into SIOY kind of under peer pressure, still not taking it very seriously, and we ended up winning some money from it. It was the first time after presenting. One, going through the process made me think about it like a real product. Two, winning some money made me think, oh wow, this is maybe this could go somewhere. I could do something with this. So we put it into another competition here at BYU, and found some more success, and went into one of the Launchpad programs through the business school, and it kind of accelerated it. Through that whole process, I still kind of didn't think it was going to go anywhere, but was hopeful, and putting some time and energy into it at least was helping me learn. So we decided, you know what, we're going to throw this thing on Kickstarter and see what happens. And if we make some money on Kickstarter, then maybe we'll actually do something with this, and we'll consider spending our time on this. And so we launched it on a Kickstarter, and it just, from our perspective, crushed it. I think at the time we were hoping we would do $20,000 on our Kickstarter, and it earned like 90. And so we were pretty pumped about that. We really didn't know what we were doing. We just threw it up there, and it took off. So me and my co-founders at the time that were helping me with it were trying to decide, what do we do? This is taking a lot of time and energy. Do we stick with it? Or do we finish school and go get jobs and do what we want to do? But I decided that I wanted to stick it out. I wanted to see where this thing could go. So we stayed with it, and fast forward from 2018 SIOY, in 2019, we were invited onto Shark Tank. So some of you may have seen that. If you search Myostorm Shark Tank, you'll find it. The title of the YouTube video is Myostorm Makes the Sharks Mad. And it was really fun. So we ended up getting offers from almost all of the sharks, and shook on a deal with Lori. And one of the secrets of Shark Tank is you have the handshake deal, but then there's months of due diligence and business negotiations happening behind the scenes. So one of the secrets that not everyone knows is after our handshake deal with Lori, there was about 6 months where we were in a due diligence process. And about 4 months into that, our episode aired. And we got so much traction and so much sales from being on Shark Tank that we kind of went back to Lori and we're like, hey, we're still really excited to do a deal, but we've like 100x'd our revenue since we shook on a deal. So we're gonna change the terms, and we actually never ended up closing a deal. So we got on Shark Tank, we got all of the fun and the excitement, but didn't actually have to give up any of the money. So that's been my journey. Fast forward a couple of years later, I built a whole team around Myostorm and the growth of Myostorm, a marketing team, and other aspects of the business. And I realized that we had success with this one business, and my team had the ability to do it with others. So I brought on a couple of other business partners, and we started bringing other e-commerce product ideas on. So now I own a company called Rep Labs, which is an e-commerce direct-to-consumer brand aggregator and incubator. So Myostorm is just one of the entities in an umbrella of about a dozen companies that I now own, several of them all multi-million-dollar e-commerce product brands. But it was really SIOY, and if it wasn't for SIOY and getting that experience and being kind of thrown into it and winning a little bit of money, none of the rest of that would have happened. So I'm extremely grateful to SIOY, to BYU Engineering, to the Rollins Center, to everyone that's been a part of this, because it skyrocketed my experience as an entrepreneur and a business owner, and has led to a lot of really amazing things. So I'm pumped for the teams, all the teams. I mean, there's people curing cancer out here. I mean, I made a little thing that buzzes and warms up, and that's like, these guys are way ahead of me, so I'm really pumped to see where you go. But take it seriously. It's been an incredible experience being an entrepreneur. So wherever your products go, push the idea as far as you can, because what you'll learn as an entrepreneur and pushing your business is going to be more valuable than most of the rest of what you'll do here at BYU. The experience I gained trying to be a business owner at the start was just invaluable. So please, teams, like, take this seriously. Use every resource you can. Talk to the mentors. Use all of the resources that these people are providing you, because it's going to skyrocket your success. And another thanks to BYU for inviting me to be a part of this. It's amazing, and I'm always happy to give back, because again, it skyrocketed everything that I do now. So thank you.
All right, thanks so much, Jono. That was awesome. And now we want to recognize some of our SIOY sponsors: David and Rachel Weedman and BYU Engineering's Weedman Center for Global Leadership. We have BYU Ira A. Fulton College of Engineering. Thank you, Dean Michael Jensen. The BYU Rollins Center for Entrepreneurship and Technology. Thank you, Associate Director Tara Lee Cook. We also want to thank our SIOY staff, the directors, student committee, College of Engineering staff, showcase judges and mentors, and our people backstage. So now, if you are a student or want to team up with a BYU student, you can compete in next year's SIOY by visiting, there's a lot of letters, sioy.byu.edu. Okay? Sign up for the email list to receive announcements and access to the competition application. And now, before we get to the judges' decisions, let's have a few more giveaways, right? Okay, we're just going to be pumping them out now. We've got 7 more giveaways, so please have them at the ready. Have your shouting voices ready to go. And if you were super disappointed that you didn't get the first one, there is another metal cup. I hear that the metal makes it do better with the liquid. Okay, 727-909. Oh, there it is. All right, come on up. And while he is walking up, I'm going to get started on our next giveaway. Yeah, I'm going to keep this. Okay, now we have Climate. We have another product from Climate, Everglow Light Tube. So it is a lamp that will light your way while you're camping, but maybe it's soft enough that you can hit people with it. Okay, that's not officially on the bag, so if it breaks, I am not liable. 388272. Oh, yeah. Oh, all right. We got someone. And for the second one, we have 981510. Did I get a shout? No? All right. For the second one, we've got 981536. Yeah? I hear a yeah. Somewhere over here. All right, sweet. There we go. We've got the climate lights. And now, oh, look at this. Who's this? This is Cosmo. Little Cosmo bobblehead, but he's an engineer. And you could tell because of the little pocketbook he has, which all engineers have. Wait, let me see. Oh, that's still a thing? All right, it is a 90s engineer. Okay, so let's see. We've got 981557. Oh. Okay, 981547. Yeah? Come on up. All right, well done. And then we've got 388319. Call it out. Call it out. Going once, going twice. Nope, the second one goes to 981552. Yeah! From over here somewhere. Awesome. Devin will be over here with your Cosmos. Cosmos. Oh, this one's cool. Okay, we got more Legos. This one also floats in space, but it is the College of Engineering building, which is pretty cool because you can build this, and then if you are ever shrunk to a tiny size, you can live in it. Okay? Now, it is 981563. Woo! All right. Come on up. And 388337. Lucky, unlucky. Is that? No? Okay. Someone like sneezed. I'm like, hey! 388311. All right. Come on up and get your prize. That is all of our giveaways today. And now, for everything that you've been waiting for, we have our judges' decisions. Oh, it's exciting. We get to find out who won the SIOY 2025. So, we are going to start with our finals favorite. We want to first thank the judges for lending their time. Please, one more time, they really take time yesterday and today to come here and to give to the students who are doing this competition. One more round of applause for the judges. And we want to invite up Dean Michael Jensen, the Rollins Center Director, or not the director, Mike Hendren. It wasn't changed in the slides, but it is the Associate Director, Tara Lee Cook. Thank you so much. And the Weedman Center Director, Nicole Stewart, all up here to help us award the winners. Thank you. All right. So, we'll start with our crowd favorite. Okay, teams, when I call you up, you come up here, you will take a picture with them on the side and then exit for the next team. Okay? Now, everyone, who did you vote for? And it is Tech. Awesome. Thank you. Thank you so much. All right, now our third place, being awarded $8,000, according to our judges, is Lunar Watch Bands. All right, thank you so much. Congratulations. The runner-up. All right, this is our second place, our silver, our number 2, and it is DryRise. All right, that means we have one left. The 2025 Student Innovator of the Year, winning $12,000. This is the big one. And we have team. Oh, it's exciting. Ready? Are you guys ready? Tech! Oh, big team. Nice. All right, I'm going to step out of the way for this. Congratulations to our winners. As they take this picture, I want to thank all the sponsors, thank our judges, thank you to all of our SIOY participants who competed, thank you to our audience, and we'll see you next year. SIO, bye!